Hello friends, welcome back to Pharma-info with Shubhashish. Now today let us just deal with another anticonvulsant, right? And anticonvulsant, that is carbamazepine, right? So carbamazepine long back, it was synthesized, right? It was discovered rather, discovered, and ever since it came into the market, right? Still it is in use, right? It's not that it's not been used, right? It is obsolete, right? It's not like that, right? Its use is still there, right? Okay. Now, as I said, it's an example of an anticonvulsant, right? So that means it can be given to the patient who is suffering from a kind of seizure disorder, right? Or the epilepsy, right? Now, without wasting much time in the pharmacological aspect and all, let's move to the synthesis. That means, and prior to synthesis, let us just try to figure out that the kind of structure that we need to synthesize, right? Sure. So let us just try to sketch the structure, build the structure, okay? Now, whether anything that this particular name is telling to us, okay? Okay. Is there anything that we can get from the name itself, right? Okay. The name says carbamazepine. Okay. So carbamazepine means, and let me tell you, apart from extracting the clues from the name and all, you should know that if you know the chemical class in which it belongs, okay, it will be an added additional things, or it will just act as a booster, okay, a booster in unveiling the mystery that is there within the structure, within the name, right? Chalo. So carbamazepine belongs to the chemical category of diacyl ureas, right? Diacyl ureas, right? So it belongs to the chemical category of diacyl ureas. In addition to this, it is also a derivative. It belongs to the another chemical category, or the other name for this chemical category is found to be iminostilbene, right? So these are the additional information, right? Okay, they just assist us in unraveling or in unveiling the mystery, right? Chalo. So carbamazepine, and what the name suggests, azepine. Azepine means 7-membered with a nitrogen. Chalo. So 7-membered with a nitrogen. Let us just draw that one. 7-membered with a nitrogen. So 1, 2, 3, 4, 5, 6, 7. Right? We're done with 7. Right? So, and what is the other thing? Carbama. That is carbamoyl. Carbamoyl. Carbamoyl is CONH2. This is carbamoyl. So let us just place the carbamoyl here. Right? So these are the two things that we can get from the name. And what about these two? Diacyl ureas as well as iminostilbene. Chalo. Urea. So NHC double bond O NH2 is nothing but urea, and diacyl means it is flanked with two bonds, rather, okay? Or rather it is flanked with two acyl system, right? Okay. But for the time being, this acyl is found to be misleading, right? Because you won't find any kind of C double bond O kind of things, right? Here. So it is found to be misleading. So what about iminostilbene? This can give us some kind of structural information. Iminostilbene. What is that iminostilbene? What is the stilbene? Stilbene is something like this. So if we just try to figure out how the stilbene looks, okay, how it looks, stilbene is something like this. CH double bond CH, then phenyl. Okay. Now, so how this can be, is it really possible to figure out or to reshape this particular entity in the form of stilbene, right? Okay. Let us just try, right? Let's just try, okay, how this can be done and all, right? So stilbene is basically ethylene flanked with 2-phenyl, right? Okay, chalo, let's see that whether can this particular centrally placed system be further reshaped into stilbene and all? Okay. Now if we just try to put 2-phenyl in both the sides and making it something like this, how it looks? अब देखो इसमें स्टिलबेन कुछ लग रहा है इसको स्टिलबेन. Now let us just remove this for our understanding whether it matches with the structure of stilbene. Let us just remove it. For the time being, just ignore. This has been hidden, right? So phenyl CH double bond CH phenyl stilbene, no? Okay, बराबर है ना? स्टिलबेन बनता है ना? तो ऊपर का हिस्सा स्टिलबेन तो बन ही गया, ऊपर से इमिनो है मतलब C डबल बॉन्ड NH है, तो अभी तो N यहाँ पे है ही, तो हाइड्रोजन रिप्लेस हुआ किससे? कार्बामोइल से. So with that we have got the entire structure with us. और कुछ बचा नहीं है इसमें, और कुछ बचा नहीं है इसमें. We are done with the structure. This is how it looks. So that means instead of mugging up the structure, you just spend some quality times with each and every compound and see, first and foremost, ask the compound whether you have to say something to me so that I can further proceed. This is the beauty of asking a compound, asking a drug, that will you say something pertaining to your structure and all. Definitely something is hidden there, right? See, we have just drawn, this particular structure has been drawn simply on the basis of what? The informations. It's not that we have mugged up the entire structure, right? It's not like that. So keep remembering that and spend some time with the name of the drug. Name of the drug. It will say, I should not say each and everything, it will say something at least, right? Chalo. Now, so this is about your structure. Now coming to the IPC naming and all. So how this IPC name stands? So IPC naming of a fuse system, and that too in two different areas, right? Fusion took place, right? In two different areas. That means two different bonds are involved. Two different bonds. Usually fusion can be taking place simply with a single bond, right? With a single bond, right? But here both the sides of this particular azepine is holding what? Is holding phenyl ring system, right? Okay, chalo. So now this is found to be dibench, right? Dibench azepine, right? So basically dibench azepine, because seven-member ring system, right? So this is found to be the base component, and these two are found to be attached component, right? So it is the attached component that has to be prefixed, right? I had already made a video on this, the nomenclature of fused I have not made yet, right? But I am trying to make. But several videos are there in YouTube, right? Go through it, right? Go through it. And several books are there. Recommend you should consult with those books and all to get to know about the fuse system and all, right? Deal with the problems, right? Problems of this fused entities and all, right? So that means the attached component need to be prefixed. So we have two attached components, they are found to be similar, right? So that likewise, this is dibench, right? Okay. We have to put something in between attached component and base component, right? What is that? The fusion area, right? So what is and this is the base component, it has to be followed dibench followed by the base component, that is azepine. Dibench azepine, right? Okay. So we are dealing with this, right? We have not come here still, okay, up till now we are done with this, right? So we have to start the numbering from here, 1, 2, 3, 4, and this is 5, right? We don't require these things, the other locate numbers and all, right? So we have come here 5, which is holding what? A carbamoyl system. Carbamoyl. You can also call it as carboxamide, no problem at all, right? Okay. 5H carboxamide, because CONH2, you can just call it as, this is acting as a substituent and this is acting as a parent, right? So likewise, the parent is holding what? The parent is holding something like benzene carboxamide, benzamide, right? Okay, likewise. So this is dibench. Now the thing is that if we go from this direction, okay, let me just make it more legible somewhat, right? Somewhat. Okay. That means you need to put what? The fused positions. That means each and every side, which need to be indicated with the help of what? Alphabet. Okay. So now let us see that if we just start going from this direction, A, B, C, D, E and F, right? Right? So what are the locations where fusion took place? This is one of the location, this is the other location. Likewise, you need to put here BF. So you need to put here BF, right? So here I have put what? B, comma, F. It's not B full stop, rather B, comma, F, right? Okay. Now, so dibench what? Dibench azepine, right? Okay. Now, so here, and so this is about this all in a row arrangement, and then 5 Earlier it was hydrogenated, later on it has been converted into CONH2. CONH2. So you can also call it as 5H5 carboxamide. So dibench BF azepine 5H5 carboxamide, or in other words you can also call it as 5H5 carbamoyl dibench BF azepine. Either of these chalega, right? So this is about the IPC naming and all. Now we'll move to the making of this, the carbamazepine, right? The synthesis of carbamazepine. So how this can be? It's a single step synthesis, right? It's a single step. No, it's a multiple step synthesis, right? Yes, multiple step synthesis. So what is that multiple step synthesis? Let us just see, right? Okay. So first and foremost, the structure is something like this. The structure is something like this, right? Okay. So what next actually? So now here, what can be done actually? Okay. So here we'll put something like this. We'll just take dibench azepine, right? Like this, right? And then what next? Here we have to put what? CONH2. That is, the carbamoyl group has to be placed. If CONH2 has to be placed, it can be placed in two steps or in one step. Either in single step or in one step. So what is that all about? Either in single step or in one step, right? If it is multiple steps, either in single steps or in multiple steps. Just now I told, no, either in single step or in one step. What is that? There is no point in telling this verbatims and all, right? So let us first see that in multiple steps how this can be synthesized, right? Okay. So here we have multiple steps. That means this can be broken down into two more fragments, right? CO and NH, right? Okay. So how this CO? So that means we are just trying to incorporate the CONH2 not at a time, rather one after another. So first let us just insert the C double bond O. How this can be inserted? We have a hydrogen here. So this hydrogen has to interact with a halogen, that is Cl. And what need to be incorporated here? C double bond O. So we have written C double bond O. To this C double bond O, which will interact? The NH. Definitely the NH will come in the come along with additional hydrogens, right? So that means that particular hydrogen should react with another halogen. So here we have got what? The second reagent, right? That is nothing but phosgene or carbonyl chloride. So what this carbonyl chloride will do? This carbonyl chloride simple as that, HCl will go off. So step one involves the making of what? Carbonyl chloride. So dibench BF azepine 5H5 carbonyl chloride. This is found to be the first intermediate, right? Chalo. To this first intermediate, what is left in the process? So we have got the first intermediate here. What is left in the process? The amination, or amination of what? Amination of this carbonyl to make it amide, right? Or carbamoyl. So what need to be done here? Simply you can bring H3N, right? H3N, NH3 in presence of ethanol, right? Ethanol is acting as a catalyst as well as the media, right? Solution phase synthesis. So it is the ammonia that will do the rest, right? That will do the rest by simply taking this Cl along with this and leaving behind what? Simply NH2. And thus we have got what? The final compound. That is nothing but dibench azepine 5H5 carboxamide or 5H5 carbamoyl dibench BF azepine, right? So with that we are done with what? The final compound. That is carbamazepine. Now if we are just opting for the second method, that is by which we can just complete the process in a single step. So how it goes? That time you have to take what? This will remain same. One of the reagent will same as that of the earlier one. That is dibench BF 5H azepine, right? 5H azepine. This found to be the first reagent. This will react with what? KOCN. That is potassium cyanate, right? potassium cyanate. When potassium cyanate reacts with this, what will happen? Definitely there is a formation of what? Carbamazepine. And we are done with the final compound. So it is the adipine dibenz adipine while reacting with potassium cyanate, there is a formation of what? I should write in this way, right? Because we know chemistry, right? We know chemistry. So why there should not be any hesitation, right? You should not like this, like an art student, right? Simply like a chemistry student, you should behave with this KOCl, right? Chalo. So potassium cyanate, while reacting with this, there is a formation of what? CONH2. Earlier this was H, and what happened? Later on, when potassium cyanate reacts with this, then there is a formation of carbamazepine. So with that, I am done with the making of carbamazepine. Hope you have you like this video. Hope you like this video, right? And if you like this video, then as usual, don't forget to press the like button. Thank you for your kind patience. Thank you.